Alright, children, we'll solve now next problem, that is question number 9. Means we are still solving important MCQ numerical questions from chapter alternating current. Okay, now question number 9. Question number 9 says that in a series LCR circuit, see, we are again dealing with series LCR circuit. The voltage across R means resistance, is 100 volt, and R is resistance only, that is 1 kilo ohm. 1 kilo ohm means 1000 ohm. Capacitance is 2 microfarad. Now the resonant frequency is 200 radian per second. So what is given? The resonant frequency is given 200 radian per second. Now what you need to calculate? At resonance, the voltage across L. Now we have to find the voltage across L. At resonance is 40 volt. The options are given, and the 4 options are given. One is A, option is 40 volt. Option B, 250 volt. Option C, 4 into minus 3 volt, and option D, 2.5 into minus 2 volt. Now in order to calculate and choose the correct option, okay, of voltage across L under electrical resonance condition, we can do the solution of this question. And the question said that in LCR series circuit, that is at resonance, okay, you need to find the what? Voltage, and this voltage is across what? Inductance. Now in voltage across resistance is given, BR is given how much? 100 volt, children. Resistance value is also given, that is 1 kilo ohm, but I convert kilo ohm into what? Ohm, that is 1000 ohm. Okay. At the same time, the capacitance value is also given, 2 microfarad, and you know microfarad means 2 into 10 minus 6 farad. So we convert microfarad into farad. Okay. Now at electrical resonance condition, now we need to find the voltage across inductance. Now to find the voltage across inductance, first of all we need to calculate the value of inductance only. Now for that we have a condition, XL equals to XC. So when we, as a electrical resonance conditions, XL voltage, inductive reactance is always equals to capacitive reactance. Okay. Now inductive reactance is given by X omega L. XL equals to omega L by XC means 1 by omega C. Okay. Now from this relation we can do the calculation of what? L. So again I make L as the subject. L equals to 1 by omega square C. This omega and omega multiply omega square, and this already C. Okay. Now in the question, angular resonant frequency, that is 200 radian per second, that is given omega, and the value of omega is how much? 200 with whole square. C capacitance 2 into 10 minus 6. Okay. So now let's calculate the value. 200 means I can write this as 2 square means 4. Okay. Now 100 means 10 to the power 2 square means 10 to the power 4 into 2 into 10 to the power minus 6. Okay. So this will be how much? 1 by 4 to the 8, and this is 10 to the power 4 minus 6 is minus 2. Now 10 to the power minus 2 I'll take in the numerator, is 10 to the power 2. Now 10 to the power 2 means 100 divided by 8. 100 divided by what? 8. Okay. Now 100 if you divide by 8, it will be 12.5, and the unit is Henry. So if you divide with the help of calculator, or you can do manually also, 100 divided by 8 means 12.5, and the unit is Henry. So inductance we got. Now after calculating inductance, we have to find the voltage across inductance, means BL we have to find out. Okay. Now BL is actually equals to IXL. See, BL equals to IXL. Okay. So when BL equals to IXL, then we have already calculated the XL. We can calculate the value of XL. Okay. XL means omega L, because for that L is already calculated. Now the current that we need to calculate. The current that we need to what? Calculate. Now the current can be calculated because we know the voltage, we know the resistance. So with this voltage and resistance we calculate the current. So let me just do this side only, because according to Ohm's law, BR equals to IR. So then I equals to BR by R. Okay. So BR means how much? 100. R means how much? 1000. So 20 cancel out. So 1 by 10 means 0.1 ampere. So children, look at it. The current that I calculate is 0.1 ampere. Now we can calculate the voltage. The current is 0.1. XL means omega L. Now omega is how much? See, XL means omega L. Okay, let me write omega L equals to 0.1 omega means 200, L, the value of L we calculate is 12.5. Okay, now if you do multiply 0.1 into 200 into 12.5 sorry, with the calculator, we get how much? 250 volt. So what is the voltage that you obtain when you calculate 0.1 into 200 into 12.5? 250 volt. So what is 250 volt? Is the voltage across the inductance. So children, you can see question number 9, correct option is option B, 250 volt. Now we go to the next question number 10. Now question number 10 say that a 50 Hertz AC source. So what is the frequency of AC source? 50 Hertz of 20 volt AC source is connected across R means resistance and C means capacitance as shown in diagram. So this is the diagram. Means this is the combination of resistance and capacitance in series, and this is also called CR circuit. Capacitance and resistance, when they are connected in series, means this is what circuit? CR circuit, connected to AC source. Okay, this is AC source, and how much voltage you are applying? 20 volt. Okay, now question says that the voltage across resistance is 12 volt. Means this voltage is given. The voltage across resistance means VR is given. Now what we need to calculate? The voltage across capacitance. Now we need to calculate BC. Yes, we can easily calculate the voltage across capacitance when you know the voltage across resistance, and even the supply voltage is given, that is 20 volt. So for that there are 4 different options given. One is A 8 volt, B is 16 volt, C is 10 volt, and last option is D, not possible to determine unless the value of R and C are given. Now we try to solve this question number 10, children. As per the value which is given, the frequency of the AC source is given F, that is 50 Hertz. So if F is 50 Hertz, now children we can calculate what? Omega. Omega means 2 pi F. Actually omega out here means what? Angular frequency. That is 2 pi into 50 Hertz. Now 2 pi into 50 Hertz means this is actually 100 pi Hertz. Sorry, not Hertz, sorry. The unit of angular frequency is radian per second. This is 100 pi radian per second. Then after in the question, the source voltage is given. Okay, that means connected to a AC source of 20 volt means B is given. This voltage is given, that is 20 volt. And connected across the resistance and capacitance in series. This are in series connection. Now voltage across resistance is given, BR is given 12 volt. Now what we need to calculate? Voltage across capacitance. So this is what circuit, as I said? CR circuit. In CR circuit, the voltage, there is a formula, the voltage B equals to square root of BR square plus BC square. So children, remember this formula. This voltage is always equals to square root of BR square, voltage across resistance, plus BC square, the voltage square, voltage across capacitance. Okay, so let's substitute the value. B is how much? B value is yes 20. Square root of BR means 12 with whole square. Now BC we need to calculate. Now we can do squaring both sides. If I do squaring both sides, children, it will be 20 square equals to 12 square plus BC square. Now why? Because if you do squaring both sides, then this square root and this square cancel out, so it will only remain this part. But 20 square I can write in the left hand side. Now 20 square means how much? 400. 12 square means 144 sorry, plus BC square. So I'll make BC square as the subject. So it is 400 minus 144. And children, if you subtract 400 minus 144, it will be 256. Okay. Now BC square is 256. Okay. But I calculate BC, so it will be square root of 256. And 256 is basically 16. And the unit is volt. So what is the voltage across the capacitance circuit? Okay, across capacitor, 16 volt. So children, I have already calculated the value, that is 16 volt, and which is the correct option? Option number B. So question number 10, option number is B is the correct option. Okay. Now we go to the next question, that is question number 11. Now this is also a question based on step up transformer. Okay, one of the type of transformer. The question number 11 says that a step up transformer operates on a 230 volt line, means this is the supply voltage, and supplies a current of 22 ampere Means how much current that is supplied? 2 ampere. Now the ratio of primary and secondary windings, means turns, is 1:25. 1:25. Now what we need to calculate? The primary current is, now from out of 4 options we need to calculate the primary current. Now there are 4 different options given. One is A, 12.5 ampere. Option B is 50 ampere. C is 8.8 ampere. And lastly, option D is 25 ampere. Now in order to choose the correct option, so let's again do the solution of this question number 11. And children, in question number 11, we are dealing actually with step-up transformer. Okay, and in this particular transformer, this transformer operate on 230 volt line, means voltage across primary. That is 230 volt is the voltage across primary. Now supply current, means current is supplied also by primary, that is current across primary passing through the primary coil is how much? 2 ampere. Now the ratio of primary and secondary winding is 1:25. Means ratio of primary and secondary winding means the value of ratio, the number of turns and primary and number of turns in secondary, that is equals to 1:25. 1:25 means nothing but 1/25. So NP by NS is 1/25. Now children, in this particular question number 11, the current, primary current actually you need to calculate, okay, but the current that is supplies through the circuit is given 2 ampere. Actually this current is the current through secondary coil. Okay, current through which coil? Secondary coil. So 2 ampere is the current through secondary coil, and we need to calculate the current in the primary coil. So this current I have written 2 ampere is not current through primary coil, current through secondary coil. Now actually you need to find current through primary coil. Okay, so to calculate the current in terms of this number of turns, so we have a relation out here, and the relation of, as per the transformer is concerned, is that current to primary coil by current to secondary coil is equals to number of turns in the secondary coil by number of turns in the which coil? Primary coil. So we need to calculate current to primary coil. So IP by IS equals to NS by NP. Okay, so from here I'll make IP as subject. It will be NS by NP into this IS will go in the numerator. It will be IS. Now out here is NP by NS is 1/25, but NS by NP means 25/1. So this ratio is just reciprocal. So NP by NS is 1/25 means NS by NP means 25/1. So I write on 25/1 into IS, current through secondary coil is how much? 2. So look at it. Finally the value will be 25 into 2 means how much? Yes, I write this side, no problem. IP equals to 50 and the unit is ampere. So 25 into 2 means 50 ampere, and that is the current through primary coil. So children, you can see the correct option of question number 11 is 50 amperes, option number B. Okay. Now we will solve next question again, that is question number 12, and question number 12 says that in an AC voltage is applied to a resistance R and an inductor L in series, means this is for LR circuit. Okay, if R and the inductive reactance are both equals to 3 ohm, means resistance also 3 ohm, inductive reactance also 3 ohm. So what we need to calculate? The phase difference between the voltage and current in the circuit is, so 4 different options are given. One is A is pi by 6, B is pi by 4, C is pi by 2, D is 0. Now in order to choose the correct option for LR circuit, so calculate the phase difference, we can simply do the solution of this question. And the question says that in LR series circuit, this is for LR circuit, resistance value and XL value is 3 ohm. Means R is also 3 ohm, XL is also what? 3 ohm. Okay. Now what we need to calculate? The phase difference. Okay. Now phase difference between the LR voltage and current in the circuit, that we need to calculate. And the formula is phi equals to tan inverse omega L by R. So for LR circuit, children, look at this. Phase difference between current and voltage given by tan inverse omega L by R. Now out here omega L, as you know, is XL, inductive reactance, by R. So it is tan inverse XL means 3 ohm, R is also 3 ohm. So ohm cancel out, 3 cancel out. So it's coming tan inverse 1, and 1 is one of the value of tan, that is what? Tan 45 degree. See, 1 is the value of tan 45 degree. So tan inverse tan 45 means 45 degree. So your phase angle is how much? 45 degree. And you know 45 degree can be written as pi by 4 also. So 45 degree or pi by 4. So you can see the correct option is option number what? B, that is pi by 4. So question number 12, correct option is pi by 4. Now we will solve other questions, okay, remaining questions, and that you learn in the next YouTube video.